Happy morning to all. Today we are going to learn about the unit 4. The previous 3 units are over. Today we are going to learn the new lesson that is called transition metal and inner transition metal. This is our new lesson. About the introduction about the transition metals, all of you know that one. The metallic elements that have incompletely filled D or F subshell in the neutral or cationic state are called transition metal. We are saying that incomplete in the D subshell and F subshell. Okay, the metallic elements they have incompletely filled D and or F subshell. Okay, F subshell in the neutral or cationic states are called as transition metal. This definition is included for the F block element, that is also called as lanthanoids and actinoids. The transition metals of an element which atoms have an incomplete D subshell. Transition metal is particularly about the incomplete D subshell. D subshells are incomplete. Maybe occupation of 1 electron, 2 electron, 3 electron, like that, up to 10 electron. The incomplete D subshell, that elements are called as what? Transition elements. Okay, here transition metals may be, mostly we are using our building materials, we are using iron, one of the transition metals, and also copper. We are using the electrical wires. These are very important, the transition metals. And also about the titanium, titanium is a manufacture of artificial joining. For our artificial joining, we are using the titanium, and also molybdenum is used for the boiler plant, and also platinum also we are using a catalyst. This is going to play a vital role in our daily life. Okay, and also about the hemoglobin also in our blood. And also about vitamin B12 and B6 etc. also having in our transition elements. Next about the position in the periodic table, where the occupation of transition metal is a periodic table. That is in the middle area, in the long form of periodic table, the modern periodic table, the transition metals as the middle of the periodic table. The one side is an S block element and another side is a P block element. Then below is an inner transition metal that is called as an F block element. The middle area that is called, we can be, there we have a 3D series, 4D series, 5D series etc. having some series. For example, the first 3D series goes to scandium to zinc, like that. Atomic number start with 21 to atomic number zinc Zn is 30. If you have 10 elements, that is the particular area having 10 elements, these are the transition element. Transition element occupying group number 3 to group number 12. Group number 3 to group number 12 is occupying in the modern periodic table. And about the group number 1 and group number 2 are the S block elements, and group number 13 to group number 18 are called the P block elements. Okay, anyhow, D block elements are compound having 3D series, 4D series, 5D series, etc. The 3D series starting with scandium to zinc, that is atomic number 21 to atomic number 30. And also about the fifth period. Fifth period means that is the 4D series. It started with yttrium to cadmium, and about and this series also having 10 elements. Okay, 10 elements. That means 3D series having 10 elements, 4D series having 10 elements, 5D series also having 10 elements. Like that, it is arranged like that in the modern periodic table. Okay, anyhow, these are about the introduction about the transition metals, and about how this is an important question, how you write the electronic configuration of transition element. Today our learning objectives. What is the learning objectives? Learning objectives means to how to write the electronic configuration of metal copper and also metal chromium. This is a very important question. Metal copper and also metal chromium. How to write the electronic configuration? Please always take your note and write the electronic configuration. The electronic configuration. The electronic configuration, how can we write for the transition model element? How can we write? Here, first you should be write fill with 4s orbital before 3d orbital. All of you know that how to write the electronic configuration. That is, first to start with the 1s, next above 2s, 2p, next 3s, 3p, 3d, next 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 6p, 6t, 6f, 7s, etc. Okay. Here all the s subshell we can be accommodate 2 electron. That is a maximum 2 electron. All the p subshell we can be accommodate 6 electron. The maximum electron 6. And the d subshell we can be accommodate 10 electrons. The maximum 10 electrons. And the f subshell we can be accommodate 40 electrons. This already we learned in the Offa principle and also Hund's rule. Okay. Here, first one. Oneness. Next 2s. Next 2p 3s. Next 3p 4s. Next 3d 4p 5s. Next 4d 5p 6s. This is the order. Okay. First to start with here 1s. Next 2s. Next 2p 3s. Next 3p 4s. Next 3d 4p 5s, etc. Okay. As per the line we should be right. Okay. Here, according to Offa principle, the electron first fill the 4s orbital before 3d orbital. Before the 3d orbital, we should be right 4s orbital. This is as per the Offa principle. Am I right? We can be right. For example, we can be right with the first element. Okay, that is a scandium. Okay, scandium. The atomic number of scandium is 21. What is the atomic number of scandium? 21. Because the 3D started with 3D is started with scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and also zinc. This is the first 3D transition element. Here, how can you write the scandium? Okay, can you say start with 1s? EC is equal to, how do you write EC? EC means electronic configuration. Electronic configuration for scandium. 1s, how much electron can be accommodated? 2 electron. 1s, the maximum 2 electron. Next one, 2s, how much electron? 2s, all s subshell we can be accommodated 2 electron. Next, 2p, am I right? 2p, how much electron the maximum? 6 electron. Next, which is the next one? After 2p, as per the line you write. After 2p, which one? 3s. 3s, how much electron? Maximum 2. All s subshell we can accommodate 2 electron. Next, there is a 10, 12 over 3s. After that, 3p. 3p is 6. Next one, 4s. 4s. Okay, right? But here, as per the transition series, before the 4s, you should be write 3d. Clear? Before, after the 3p, don't write the 4s. Before the 4s, you should be write 3d. So 3p, then you should write 3d. Next, last you should be write 4s. Okay? So okay, 4s, all of you know that one. How much electron? 2 electron. Okay, now we count it. 2, 4, 10, 10 plus 2, 12, 18, 20. Scandium is about 21. So 3D1, 4s2. Clear? Can you write? Have it out? As per you should be right this order, that is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Then only you should be right 3D. Am I right? As per the transition series, according to alpha principle, the electron first fill the 4s orbital. The 4s orbital. The electron first fill which one? The 4s orbital before 3D orbital. Okay. Okay. First you write which one? First fill the 4s orbital before 3D orbital. Here. So as per here order, we write this one. It is a scandium. Then how can you write the short form of this electronic configuration? This we wrote in a full form. How can we minimize? How can we short this electronic configuration? That we can be written as the nearest noble gas. Nearest noble gas. Yesterday I told you about the noble gas. About the what is the atomic number of helium? Helium we can be written as 2. Next neon 10. Argon 18. Krypton 36, etc. Okay, etc. I'm not writing full. Okay. Here the nearest noble gas. Which one is the nearest noble gas? The scandium atomic number is 21. Nearest 21. Nearest which one is? That is 18. Okay, am I? So we can be written as 18. 18 is the nearest noble gas. That is argon. Am I right? So we can be written as argon, scandium, argon. Argon how much over? That is 18 over. Am I right? 18 over. That means 18 means 1s2, 2s2, 2p6, 10 over. Next about 2, 12 over. Then 16. Okay? 10, 12, 12 plus 6, sorry, 18, 18 over. For writing this much configuration, it should be cut short and write, that place it should be write argon, AR. You should be write the remaining configuration, that is argon, 3D1, 4s2. This is the electronic configuration for scandium. Okay, can you write this one? Instead of this one, this configuration, you should be cut short and write argon. Clear? Argon, 3D1, 4s2. This is the configuration for scandium. Clear? And also, here, the filling of 3D orbital is complete in zinc. Okay. Here, in the 3D series, the last element in the 3D series, that will start with scandium. Scandium 2 ends with Zn. Zn means zinc. What is the atomic number of zinc means? Atomic number is 30. What is the atomic number of zinc? Atomic number is 30. Then how can we write the atomic number of electronic configuration for zinc? Okay, electronic configuration for zinc. We can write that down. Once again, start with here. Electronic configuration of zinc, that is equal to 1s2, 2s2. Next one. After the 2s, 2p6. Next, after the 2p, 3s2. Next, 3p6. Next, 4s2. Okay, don't write the 4s2. You should be write 3D. Okay, 3D 10. Next, after 3D, then write 4s2. Okay, the atomic number of zinc is 30. The nearest noble gas. The nearest noble gas is not krypton. The nearest is which one? Argon. Okay, krypton means again we need more than 6. Am I right? 36 is the krypton, but zinc the atomic number is 30. So the nearest is argon. So for writing this configuration, we can be minimized, we can be cut short. Electronic configuration Zn is equal to, how do you write? This much we can write argon. What's the remaining? 3d10 4s2. This is the electronic configuration of Zn, zinc. Can you write? And filling the 3d orbital is complete. Is it complete? The d subshell is complete or incomplete? The d subshell is complete for zinc. Its electronic configuration is argon, 3d10 and 4s2. Okay. So, and one more problem is from the problematic question. Write the electronic configuration for chromium and also copper. Write the electronic configuration for chromium. The chromium symbol is Cr, chromium metal. Chromium. The symbol of chromium is Cr. Okay. The atomic number of chromium. The atomic number of chromium is equal to 24. How can you write the electronic configuration of chromium? This is one of the 2-mark question. Electronic configuration of chromium and also the electronic configuration of copper. Okay. First you write the chromium. Okay. Start with 1s. Ec is equal to, electronic configuration is equal to, start with 1s, 1s2, next one, 2s2, next one, 2p6, after the 2p, 3s2, next one, 3p6, next one, don't write the 4s, 3d, next 4s2, okay, 4s2, okay, 4s2, can you write? Okay, and now you count the atomic number. 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12, 12 plus 6, 18, 18 plus 2, 20, okay, don't write here 4, if you are writing 4 means 24, it is okay. The electronic configuration of chromium is okay. But it is wrong. Okay, you should be add 1 electron to d subshell. That is 3d5 4s1. Okay, how will you write? 3d5 4s1. This is the correct electronic configuration. The actual electronic configuration, that is okay. 3d4 4s2, that is okay. But it is the correct electronic configuration. We are expecting the d subshell is half filled. For example, they are writing the half filled stability for the stability. This is the 3d subshell. Okay, if you are writing 5 electrons, that is 1, 2, 3, 4, 5. This is stable, 3d5. 3d5. So we are writing like that. And about the 4s, this is stable. Half filled. These are all what? 4s1, 4s1. This is half filled. This is the actual correct electronic configuration of chromium. How will you write? Here, this can be cut short and we can write the cut short. That is a short form of writing. We can write as Ec is equal to, instead of this, we can be write argon. Am I right? Argon. Because the atomic number of argon is 18. Okay, so it should be right 2, 4, 10, 12, 12 plus 6, 18. So argon, next remaining 3d5, 4s1. This is the electronic configuration of chromium. Can you write? Have it out? Next, and also one more question. Write the electronic configuration of copper. Okay. Write the electronic configuration of copper. What is the symbol of copper? Cu. The symbol of copper is Cu. The atomic number of copper is 29. What is the atomic number of copper? 29. Then how will you write the electronic configuration of copper 29? Start with 1s. Electronic configuration of copper. Start with 1s. 1s, how much electron can be accommodated? All the s subshell can be accommodated. The maximum electron is 2. All the p subshell can be accommodated. The maximum electron is 6. All the d subshell can be accommodated. The maximum electron is 10. And all the f subshell can be accommodated. The maximum number of electron is 4d. So 1s, 2. Second one, the line is over. The second line, 2s, 2 starting with here, okay? The ends with here. The ends with the arrow. And next one, 2p6. After the 2p, 3s. 3s2. Next, 3p6. After 3p6, don't write for us. 3d. 3d, 10. Next one, 4s. 4s1. Okay? Shall we count this one? 2. 2 plus 2, 4. 4 plus 6, 10. 10 plus 2, 12. 12 plus 6, 18. 18 plus 10, 28. 28 plus 1, 29. This is the actual configuration. Okay? Then how can you write the short form of this electronic configuration of copper? Short form. How can you write the electronic configuration? Short form. For writing this much, we can be write AR. Am I right? So we can write as argon, because the atomic number is 18. So argon, what's the remaining? 3d10, 4s1. If you write like that, if you are writing actual configuration, that is AR 3d9, 4s2 means it is not a stable form. Okay, this is not a stable form. Wrong. This is the correct, because 3D subshell begins to completely filled for the stability. Okay, 3D subshell is completely filled. Okay, in case of copper and also chromium. Okay, write carefully. Okay, it's a very important question for the 2-mark question. Argon 3D10, 4s1. This is the electronic configuration of copper. Okay, and also the electronic configuration. What is the general electronic configuration of d block element? That is the question. What is the general electronic configuration of d block element? D block element general electronic configuration. We are writing one noble gas, okay? Noble gas. For transition metal. General electronic configuration for transition metal we can written as noble gas. N minus 1. We are taking N minus 1. Okay. N minus 1 D 1 to 10. Can you write? N minus 1 D 1 to 10 and also NS 1 to 2. Okay, that is the general electronic configuration of transition metals. Here N is equal to 4 to 7. Here N is equal to 4 to 7. Okay, listen all of you. This is the method. This is the actual general electronic configuration for transition metal. That only we wrote in the previous scandium to zinc. Am I right? Here we should be write 1. The D subshell should be accommodate the electron 1 to 10 and also n subshell we can be accommodated 1 to 2. Clear? This is the, here we are using the nearest noble gas. Sometimes it may be neon. Neon is not possible. Argon. Sometimes krypton. Okay, xenon, like that. Which noble gas is nearest? We should be writing the nearest noble gas there. And also n minus 1, D 1 to 10, ns 1 to 2. This is the general electronic configuration for transition metal. Okay, and also this is for the and about for the inner transition element, that is F block element. Inner transition element for FR metal. Okay, FR metal. We can written as noble gas. Here we are using, here n minus 1, here we are using n minus 2, n minus 2, okay, here n minus 1, n minus 2, here having D subshell, and here having F subshell. F subshell means we are using 14, okay, here we are using 14, and next n minus 1, again we are continuing n minus 1, D 1 to 10, ns 1 to 2, ns 1 to 2. This is the F orbital, that is, here we are using that is F block element, the general electronic configuration. Okay, for the F block element we are using the general electronic configuration, that the noble gas n minus 2 F 14, n minus 1 D 1 to 10, ns 1 to 2. What about the transition metal here? What is the transition metal about? Noble gas 1 minus 1, D 1 to 10, ns 1 to 2. Okay, this is about the one-word question. Next, about the metallic behavior. What about the metallic behavior? Metallic behavior, all transition metal element, all transition elements are metal, all are metal. Okay, all transition elements are metal. Transition elements are good conductors and heat and electricity. Okay, good conductors. About the metallic behavior, first one, all of you know that one. All transition elements are metal. They are good conductor of heat and electricity, and except the 11th element, the group 1 and group 2 of the transition elements are hard. Here, group 1 and group 2, all the transition metals except 11th elements are hard. Okay, and also silver has the highest electrical conductivity at room temperature. This is the one-word question. Which metal has the highest electrical conductivity at room temperature? That's a one-word question. Silver has the highest electrical conductivity at room temperature. Next, about the melting point. Melting point about the transition metal. Melting point about the transition metal. Here, the first condition, we are plotting the graph about versus Kelvin. Okay, plotting the one of the graph versus Kelvin in 3D transition series. Kelvin. This is for the 3D. Okay, 3D series element. Okay. First scandium. Start with the scandium, the 3D series having 10 element. Am I right? 10 element. After this, the 10 element, first start with scandium. Now the scandium, the melting point is slightly increasing. Okay? Slightly increasing. then again it should be increasing. This is scandium, this is titanium, okay, and then titanium, this is about the vanadium, then light almost constant value to chromium, okay, chromium, okay, then about the melting point is decreasing for manganese, Mn, okay, this is now decreasing, and iron is also slightly increasing, that is Fe, okay, that is ion, Fe. Next about cobalt and about the nickel, okay, cobalt, nickel, and again copper. Next about zinc. This is the condition. Okay. First scandium. Here you should be learned the scandium. What is the melting point of scandium is 1814 Kelvin. Okay. What is the melting point of scandium? 1814 Kelvin. And also about the vanadium. Here take the vanadium 2183 Kelvin, okay, 2183 Kelvin, and about the come nearest close to chromium. Next melting point is 2180 Kelvin. These are all the one word question, okay. First, what is about the scandium melting point? 1814 Kelvin, which is slightly increasing about 2183 Kelvin. Next, almost close to chromium, that is 2180 Kelvin. Next, about the melting point is decreasing, that is 1519 Kelvin, 1519 Kelvin for manganese. Next, about also slightly increasing and again decreasing, and comes to last also decreasing. Here, why it is decreasing? That's the question. Why Mn is decreasing and also Zn decreasing? Here, one of the very good question. It is due to D5 configuration. Which configuration? D5 configuration. D5 configuration. What is about the D5 configuration? Let us we can be discussed. Okay. Anyhow, the first series, the melting point increases. The first series means we are taking 3D series, 4D series, 5D series, 6D series, etc. Am I right? That is the first series, that is 3D series. The melting point is increases from scandium. What is about the maximum melting point? 1814 Kelvin, and to a maximum about vanadium 2183 Kelvin. Okay, which is close to 2180 for the chromium. Am I right? However, the manganese 3D series, that's and also technetium in 4D series. It is also happened in 4D series. 4D series, that is instead of magnesium there is a technetium. 4D series technetium, and 3D series is manganese. Okay, and they have low melting point. Okay, low melting point. And about the maximum melting point about the middle of the transition series indicates D5 configuration. D5 configuration. How can you calculate the D5 configuration? Okay, we can write that one. That is easy. Electronic configuration. How will you write the electronic configuration for manganese? Okay, that means atomic number of manganese is 25. Manganese atomic number is 25. Okay, how will you write electronic configuration? Argon means that is 18 over. What's the remaining out of 18? 3D 3d 5 4s2. Clear? That is 18 over 18 plus 20. 18 plus 2, 20, 25. This is the electronic configuration of manganese. Okay, please do it. Write the full this electronic configuration as per the Offa principle. You should be right. Then we get the answer argon for the manganese. Argon Ar, that is 18 Ar 3d5 4s2. 3d5 4s2. Okay, here Mn2 plus, what is the configuration? This is for manganese electronic configuration. But I am asking the question, what is the Mn2 plus configuration? Mn2 plus. Mn2 plus means it is a loss of 2 electron. Loss of how much electron? Loss of 2 electron. Loss of 2 electron. That means this manganese lost 2 electron from S subshell, not D subshell. It lost which subshell? S subshell. So the electronic configuration of manganese 2 plus is equal to argon 3d5. Here it lost 2 electron from S subshell. So the configuration become 3d5. 3d5. Okay, 3d5. This is about the flow chart. That is the graph plotting. We get the this answer about the melting point slightly increasing, from starting with decreasing, then increasing, then decreasing, then increasing, then decreasing. And about also Zn2 plus. Zn2 plus means it lost 2 electrons. What is the actual electronic configuration of Zn? Zn means zinc. The atomic number is 30. What is the atomic number of zinc? 30. How do I write the electronic configuration? Ec is equal to argon. Argon means the 18 over, out of 30, 18 over. What's the remaining? 3d10 4s2. That is 18 plus 2, 20. 20 plus 10, 30. Okay, now what is Zn2 plus? Zn2 plus means it lost 2 electron from 4s subshell. So what is the actual configuration? Argon 3d10 configuration. Argon 3d10 configuration. Clear? Assignment. Today assignment. Write the electronic configuration. Configuration of chromium and copper metal. Okay, write the electronic configuration of chromium and copper metal. Okay, thank you all of you. Thank you. Have a nice day.